Okay, so let's begin today's lesson with a little investigation. We're looking at a table here, and I've actually filled it out for you just to save some time. Okay, but if you want to try it on your own, you can just choose some arbitrary angles. So I've chosen these angles here for no particular reason other than they are easy to calculate. If you notice here, I have all these angles, and I just filled out this entire table. So for example, I did the sine of 30 degrees gives me 0.5. The cosine of 30 degrees again gives me 0.8660, and the tangent of 30 degrees gives me that number there, 0.5774, and the whole table is just generated in that manner. Now if you look, you'll notice some pattern going on here. Okay, a lot of the same numbers keep reappearing just with the sign alternating. For example, I have, let me just erase everything first to clean up the screen. I have, for example, sine of 30 is 0.5 and cosine of 60 is 0.5, sine of 150 is 0.5, cosine of 300 is 0.5, and the same thing with the negatives. We've got negative 0.5 over here, and over here as well. Notice for tangent, I have all these other values, like the 1.7321. Over here as well, they're negatives. Anyway, it's just keep that in the back of your head as we move along with this stuff. So what can we say about the values of the trig ratios in quadrant 1? Okay, which of them produce a positive ratio? So quadrant 1 is everything over here from 0 to 90 degrees. Which one is positive? Well, both sine and cosine are going to be positive in that quadrant. So I can write down here that in quadrant 1, I have sine, cosine, and, sorry, I forgot, tangent as well. Okay, those are positive values too. So I have sine, cosine, and tangent. Now in quadrant 2, that's over here, 90 to 180. The ones that produce a positive ratio are just sine, which is over here. The sine of 120 and 150 produce positive trig ratios. So over here we just have sine, so I'll just write S-I-N like that. And finally, well, not finally, almost there, quadrant 3, 180 to 270, the one that produces a positive ratio is tangent. Those are both positive values. So I can write tangent. And in quadrant 4, that is the last line, and there was a typo over here. Just make sure you correct that. The one that's positive is cosine. Okay, tangent over here is negative, sine is negative. So I can say that cosine is positive. Just change that, looks like an E. Cos is positive. So let's look at that in our Cartesian plane. Okay. Over here I have sine, cosine, and tangent are all positive, so I can just say all. Over here from 90 to 180 I have sine is positive. In 180 to 270 I have tangent positive, and in 270 all the way to 360, which is the same as 0, one full circle, I have cosine positive. Let's summarize that on the next page. So what I have here is just, I've dropped the rest of the letters and I just have A for all trig ratios, S stands for sine, T stands for tangent, and C stands for cosine. And if you put those letters together, we get what is known as the C.A.S.T rule. So we have C.A.S.T. So it's something similar to SOHCAHTOA. It's just a mnemonic device to help us remember what is positive in what quadrant. So over here at the side, I've just summarized everything that we did above. You can copy that down into your notes. And just one piece of terminology before we go into our first example. Okay, when we're talking about angles relative to the x-axis, first of all, the angle that is made with the x-axis, okay, this one here, let me put that in red. This angle here is called the reference angle. Okay, and in the examples ahead, we're going to denote that by alpha. Okay, alpha is just a letter from the Greek alphabet. It's the first letter, and just like theta, it represents an angle. The terminal arm over here is just the arm we need in order to make that angle. Okay, and all angles, they're measured counterclockwise from the positive x-axis, or where it's 0 degrees. We'll get started on example 1 and look at how the C.A.S.T rule works within the Cartesian plane. Okay, we're going to start off with example 1. We're using the C.A.S.T rule to determine other angles, okay, that will give us the same sine value. So here we're looking at sine of theta equals 0.5. And we start off by finding the reference angle alpha just by using basic trig. So I'm going to write the question here again. So I have sine theta, but I'm going to replace that by alpha equals 0.5. And by taking the inverse of sine of 0.5, I get my angle alpha, which in this case is going to be 30 degrees. Now let's go to the grid. So 30 degrees relative to 0 is going to be roughly here. I'm just drawing a rough sketch so I see where that angle is going to be relative to the x-axis. I'm going to draw it in. That's 30 degrees. And there is my first angle. So we know that according to the C.A.S.T rule, sine is positive in quadrants 1 and quadrant number 2. So in quadrant number 2, I need to draw that reference angle once again relative to the x-axis. That's going to be over here. I know this is 30 degrees. These are right angles, by the way. And I measure my angle relative to the 0 degree, or to the positive x-axis, which in this case is going to be 150 degrees. How did I get that 150? Well, I know that a straight line is 180. And I know that I'm going back 30 degrees because that's my reference angle. So I'm going to minus 30 degrees. And that gives me my 150. So to answer this question, our two angles are 30 degrees or theta equals 150 degrees. If you want to check, you can go on your calculator and actually do sine of 150 degrees and you'll get 0.5. So in example 2 right now, we're looking at the same type of question. We're trying to find all possible values of theta between 0 and 360 degrees such that the cosine of theta is 0.5. So I'm going to start off step number 1 and rewrite my question in terms of alpha. So I'll have cos of alpha, which is my reference angle, equals negative 0.5. This implies, and that's what the two arrows mean, by the way, is implies that alpha is going to be the cosine inverse of negative 0.5, which is equal to, you probably want to check this on your calculator just to make sure for yourself, is equal to 120 degrees. So 120 degrees, that is going to go from 0 all the way to here, roughly. I'm not drawing it to scale. I just want to indicate that the angle is going to be in the second quadrant. And I know this is 120 degrees. So the angle made relative to the x-axis is going to be, well, 180 minus 120 gives me 60 degrees. That's this angle here. So I know that cos is negative in quadrant 2 as well as quadrant 3. So my other angle is going to come down here using the symmetry of the triangles. Now there's 60 degrees, that's 60 as well. And my angle, I'll do it in another color, is going to go from 0 all the way to here, which in this case is 180 degrees plus 60 degrees, which equals 240 degrees. And there's our second angle. So this we answered pretty much. It's negative in quadrants 2 and quadrant 3. And our two angles, this has been cut off on the page, I apologize. So the first one is going to be 120. The second one is going to be 240 degrees. Again, if you want to check, what you can do is actually evaluate cosine of 240, and you will find it's equal to negative 0.5. Okay, here I'm looking at example number 3. It's just like the previous two. The only difference is that instead of using sine or cosine, I'm using tan of theta. So I begin my process of finding the angles satisfying tan theta equals 0.7536. They have to be between that range by rewriting it in terms of the reference angle alpha. So I have tan alpha equals 0.7536, which means that alpha equals the tan inverse of 0.7536, which in this case equals 37 degrees. So again, check that on your calculator, make sure you know how to use it and that you do get 37. If I look at that on my Cartesian plane, or my polar plane as it's called, I actually go from 0 up 37 degrees. Again, this is not to scale. I know that's 37 degrees. So there's my first angle. Now my second angle, I have to look at, well, where is tan positive? According to the C.A.S.T rule, okay, C.A.S.T, tan is positive in quadrant number 3. T stands for tan positive. And the way I write that, well, 37 is my reference angle. I draw that relative to the x-axis, and I'm measuring that angle relative to 0 degrees. And there we go. How do I get that value now? Well, I do 180, that's one straight line, plus the extra 37 degrees, and that yields 217 degrees. And that's my second angle. So my two angles, this is quadrant 1 and 3, my two angles are 37 degrees, or theta equals 217 degrees. Check that out. Make sure that you're right by inserting 217 into tan, and you'll notice that you get the exact same answer as this here. Okay? Now in example number 4, we have 3 parts here. We've noticed that now the value of sine is not going to be a positive number, it's going to be a negative number. Okay? So where is sine negative? Where do we know that our angles are going to be? Well, again, I'm going to write out the C.A.S.T rule here. cosine is positive, all are positive, sine is positive, tan is positive. We know sine is going to be negative in quadrants 3 and quadrant 4. So it's going to be, the angle is going to be here and here. Let's figure out the first one by finding the reference angle alpha. So I rewrite this as sine alpha equals negative 0.454, which implies that alpha is equal to the sine inverse of negative 0.454, which gives me, in this case, negative 27 degrees. Now, negative 27 degrees, intuitively what that means, well, remember, if positive goes this way, then negative is going to come this way. So negative 27 degrees is going to go from 0 backwards 27. So that'll be negative 27 degrees. But we can rewrite that same angle in another way, okay, using its positive value. How do I get there? Well, instead of going counterclockwise, we go counterclockwise all the way around, and we get, what is it, 360 minus 27? I get 333 degrees. Okay, that's my first angle. In fact, you want to do the check, go sine of 333 degrees, and I pretty much guarantee you will get that number. Again, make sure your calculator is in radians, in degrees and not radians. Otherwise, you will get something else. Okay, radians are used in grade 12. For grade 11, we're going to use degrees only. So I know sine is negative in quadrants 3 and 4. Okay, just reading what's from before. And I know that one of my angles, which I already found, is 333. But what about now in quadrant 3? Well, let me take the red. 27 is my reference angle. Let me look over here. Again, make a symmetrical triangle. And I know that this angle here is going to be 27. Everything's measured relative to the x-axis. And I add to 180 27, which gives me 207 degrees. So my other theta is going to be 207 degrees. Let's take a look now for part B. Same scenario, I have a negative value for my cosine of theta, which means that according to my C.A.S.T rule, I'm going to be in quadrants, let's see, 3. I'll be in quadrant 3 because cosine is negative there, as well as quadrant 2. Let's rewrite everything in terms of alpha. So I have cosine alpha equals negative 0.3584, which implies that alpha is the inverse of 0, that's a negative 0.3584, which is equal to 111 degrees. What does that look like in my grid? Well, 90's there, 111, I'd say right there roughly. I just want an idea of where my angle is going to be, and I know that's 111 degrees. We know this already, 2 and 3. Now the second one. Well, the reference angle here to the x-axis is going to be 180 minus 111, which is, in this case, 69 degrees, which means my other angle, again measured from the positive x-axis, is going to come around here. And I get this by adding 69 degrees to 180 degrees, which gives me, in this case, 249. So my two angles are 111 and 249 degrees. For 10, I'll let you try that on your own. Consult the solutions or the filled out form just to check that your answer is right. What you should end up with, I'll tell you right here, at the very end are the angles 92 degrees and 272. Again, the process it follows is the exact same as the previous two. Here in example 5, we're changing things up a little bit. Okay, in this case, I'm looking for angles that have the same value as cosine of 161. So cosine of 161, well, first of all, let's find the angle 161. Where does it lie? I know it's going to be in quadrant number 2, somewhere out here. So I'll just draw this rough sketch. I have 161 degrees. And my reference angle here is going to be 180 minus 161, or 19 degrees, which means that my other angle, okay, again, I'm looking at, I know cos is going to be negative in this region, so it's going to be negative also down here in quadrant number 3. I will have 180 plus 19, and that gives me 199. From here all the way to here is 199 degrees. So let me just summarize what I've done so far. Cos of 161 degrees, if I plug it into my calculator, I get 0.9455. And therefore I know that it's going to be negative in quadrants, negative in quadrants 2 and 3. So my other value, which I just did for you, 161 and 199, is going to be that. But now it says two other angles, okay? So 161 is not one of those angles. I mean, it is an angle that will have the same cosine value as 199, but I need one more. The reality is that I can find infinitely many more. All I have to do to get to that angle again, let me blow this up, I'll use a different color, is whatever angle I'm at, I just add 360 to it. Here's what I mean. So for example, let's take 161. If I add 360, so 360 degrees plus 161 degrees, that gives me 521 degrees. How, well, I mean, you can plug it into your calculator and find that I'm going to get the exact same cosine of 521 as if I were to plug in 161. But in terms of the actual picture, what that looks like is I'm starting from 0, I'm going counterclockwise 360 degrees, which is to there, and then I'm going an extra 161, which takes me to the exact same terminal arm. Okay, and if I added another 360, I could continue the pattern, get to that point. Okay, and then I can keep on adding 360s and find as many as I want. And the same thing holds for if I were to start from, say, the 199. I add 360 to that, it'll get me the same value. I just go around. Again, all angles are measured from the positive x-axis, so I should actually start from 0. That'll give me another value such that if I take the cosine of it, I'll get the exact same function value as cos of 161. This question, however, just asks for 2, and I will leave it at that. So I'll say that my second one, in this case, is 521. So 521 degrees. Okay, try finding some other ones on your own and verify by taking the cosine of those values. You'll notice that it's the same as the cosine of 161. Okay, that's a good independent way to check that your solution is correct. In example number 6 here, we just want to find the basic trig ratios given a point. This one is 2, -4, and it lies on the terminal arm. So 2, -4 means I go out 2 and down 4. So that'll bring me to this point here, across 2, down 4. The terminal arm goes through that point. So let me just draw a straight line connecting the origin to that point. And I'm trying to find values sine, cosine, and tan theta. So first of all, what is the angle theta? What is theta? Theta is going to be measured from here all the way around to here. Okay, how do I figure that out? Well, look what I'm going to do. I'm going to draw in a right angle triangle. I know that this side is -4 because it goes down, and this side here is +2 because it goes across on the positive x-axis. I can use Pythagorean theorem to find my hypotenuse. I know that h is equal to the square root of 2 squared plus -4 squared, which gives me the square root of 20, which if I simplify, I get √4 times √5, which is just 2 √5. And that is my hypotenuse. So my hypotenuse is 2 √5. Let's look at now for sine. So when determining the value, we have to look at our reference angle, so the one that it makes with the positive x-axis. So in this case, let's call this alpha. Sine is going to be opposite over hypotenuse. So I get sine theta equals -4 over 2 √5, or I just get -2 over √5. For cosine, I get, let me just erase this. For cosine, I get 2 over 2 √5, because I know that cosine is going to be positive. I can write that as cos theta equals 2 over 2 √5, which just becomes 1 over √5. And for tan theta, going back to my diagram, using my reference angle alpha, just put that back. Using my reference angle alpha, I know it's opposite over adjacent, so -4 over 2, -4 over 2, which just equals -2. Those are the answers I'm looking for. That's it. Okay. What angle does, in center position, does the point P represent? So point P is this point here. Okay, this is 2, -4. What angle does it represent? Well, we measure it relative to the positive x-axis. So again, in a different color, I'll retrace what I just did. I'm going counterclockwise to here. But in order to do that, I need to figure out my alpha. So let me take any one of these trig ratios. Okay, say I take cosine theta equals 1 over √5. That tells me that theta in this case is going to be -63 degrees, which is my reference angle. So I know that this here is -63 degrees, which means that from the positive x-axis to there, I get 360 minus 63, which is just going to be